All right, so this is a data structures and algorithms for Java course, and if you want to use a linked list in Java, you're probably going to use the linked list class in the JDK. So here we are at the Java doc for the linked list class, and the first thing we'll notice is it says this is a doubly linked list implementation. And so if you use this class, you're actually getting a doubly linked list, not a singly linked list. We'll also notice that it implements the list interface and the DQ interface. We're going to look at queues later. Now, because it implements the list interface, all the methods in the list interface are in the linked list class. So we have methods like add, index of, size, to array, remove. Now, this class uses generic, so you can use this linked list class with any type of object, including our employee object. Now, what about the node class? Well, the linked list class has its own implementation of the node class, so we don't have to write a node class ourselves. Now, it's important to note that this class is not synchronized. This implementation is not synchronized, so if you want to use a linked list instance from multiple threads, you'll have to synchronize the calls to any of the linked list methods. You'll have to do that yourself. All right, let's go over to the IDE. So I've created a new project. I've put the code into package academy.learnprogramming.jdk linked lists, and I've created the usual employee instances. To do that, I've obviously copied over the employee class that we've been using, and it's the exact same class. I just copied and pasted the code over from one of the other projects. So let's create a linked list for our employee. So we'll say linked list employee list equals new linked list. And it's going to ask me to raise my language level because the default language level is 1.6 and I believe this needs 1.7. So I want that light bulb to come up, not that one, the red one. There it is, and I'll just say set language level to 7. Okay, so let's do what we did before. We'll add a bunch of employees to the front of the list. So I'll say list.add first. So this is the method you call if you want to add an item to the front of the linked list. And we'll add Jane Jones. List.add first John Doe. List.add first Mary Smith, and list.add first Mike Wilson. The linked list class doesn't have a handy print list method, but it does have an iterator, so that's how we're going to print what's in the list. So we'll say iterator, and I'll call it iter equals, and you'll notice there's multiple choices here for iterator. So I'm going to press Alt Enter, and I want the java.util iterator equals list.iterator, and then while iter.hasNext, we'll just print out iter.next. We could also use a for loop to print out the list. I'll put that as a comment. So we could say for employee in the list system.out.println employee. So we could do that. And I'll put this in a comment just so that you can see. So both of these will print the list. Now, obviously, it's not going to have the nice arrow that we had. We're going to be printing each employee on a single line. Well, I suppose I could add that in myself. So I'll say system.out.print head. Pretty much do the same thing we did before, and then I'll change that to print. And then I'll say system.out.print, and we'll do the double arrow because this is a doubly linked list, and then at the very end we'll print null. So now we're doing the same thing that we did in our print list, except we're using an iterator to print out the items. So let's run. And we'll see that we have the same thing we had before. We've got our head, and then we've got Mike Wilson, Mary Smith, John Doe, and Jane Jones. So let's say we want to add bill end to the end of the list. So right now we've got add first. And so let me create a bill end employee. I'll add him up here. So employee bill end equals new employee bill end. And I think his ID that we gave him in the last video was 78. Now we can't use add first because add first adds to the front of the list. And so instead, we use the add method. So for linked lists, the add method adds an item to the end of the list. It adds it at the tail. And so we want to add bill end at the tail. I'm going to copy this code. I suppose I could put this in a method, but we'll just go with this for now. Don't need to declare the iterator again, and let's run. And so Mike's still at the front of the list. Everybody's in the same position, except at the end we have bill end. So this is important to remember when you're working with the JDK linked list class. The add method, the implementation of the add method from the list interface, adds the item to the end of the linked list. If you want an item added to the front, you have to use the add first method. So it's important to read the description of the method you want to use to make sure it's adding the item where you want it added. Now we could also use add last. So if I change this to add last and run, we'll get the same thing. So we'll see that bill's been added to the end. So you can use add, or if you want to be really clear that you're adding the item to the end of the list, you can use add last. Okay, I'll close this down again, and let's go look at the code for linked list. So I'm going to right click and say go to the declaration, and we'll see that it is using a node class, first and last. So first is basically the head, and last is the tail. It's got a size, and so this looks familiar, doesn't it? Now, what's the underlying data structure being used for the linked list? Remember when we looked at array, list, and vector, we discovered that it was an array. Well, we'll see that the class extends abstract sequential list. And if we take a look at that, we'll see that this kind of provides a skeletal implementation of the list interface to reduce the amount of work required for classes that want to implement list. So basically, if you want to implement the list interface and you don't want to start from scratch and have to implement every single method, instead of just implementing list, you can extend this class if you want a sequential list, and you get a bunch of stuff for free, and then you can just override what you want to override. And that's all fine and dandy, but how is a linked list being stored? Well, you can see how it's being stored. It's exactly similar to the way that we implemented our simple singly linked list and doubly linked list. The linked list itself is the data structure, so it's not being backed by anything. The linked list is just containing references to a head and a tail, and this node class, let's have a look at it, has the item, which is, in our case, would be the employee, and then it's got next and previous. So the linked list itself is the data structure. There's nothing that's backing it. And since we went through a simple implementation of a linked list, this should look familiar. And that's why we went through those simple implementations, so you have some idea of what's going on underneath the covers when you're working with a linked list. Okay, so let's go back to the main method. So we've added employees. How do we remove them? Well, if you guess that there are remove first and remove last methods, you're right. So let's go ahead here. I'm just going to copy this whole thing. Instead of adding last, let's remove the first. And we don't have to pass anything because we're always going to remove the first item here. And let's run. And we'll see that Mike is gone because we call it remove first. Mary is now the first item in the list. And if we go to the end, Bill's still there. But if I copy this code again and say list.remove last, Bill should now be taken from the list. And let's check it out. So Mary's still first on the list, but if we go to the end, we'll see that Bill is now gone. And so that's how you remove items from the front and the end of the list. You have to be careful though, because, let me just close this down. When we were talking about add, I said if you just call the add method, it will add an item to the end of the list. While in the remove case, if you just call remove like this, it will remove the first item on the list. So as I said, make sure that you always, let me just undo that. Make sure that you always read the description of the method you're using to make sure that it's going to be operating at the end of the list that you want it to be operating at. So there are other removal methods. For example, you could remove a specific employee. Of course, that would mean that the method has to search the list for that employee, and so it's going to be a slower operation. There are also methods that let you insert an employee or a node at a specific point in the list. You know, you can say something like insert Joan as the 6th employee in the list. But again, if you do that, those operations are going to be slower. The quickest operations are going to be those that are working at the head or at the tail. Anyway, I encourage you to take a look at the LinkedList class and see what's available. The important point here is that if you want to use a linked list in Java, you can use the LinkedList class as long as you don't mind the extra memory overhead due to the next and previous fields. If you're going to need a lot of nodes and memory is tight, you might want to consider another type of data structure, or if it makes sense, you might want to implement a singly linked list. But most of the time, memory won't be an issue. Now, before we leave linked lists, I'll just mention that there's another type of linked list called a circular linked list, and this is a variation on the singly linked list. And in this variation, the last node in the list doesn't point to null. Instead, it loops back and it points to the head of the list. And one advantage to this is that you can traverse the entire list starting at any node. So if for some reason that feature is important to your application, then a circular linked list might work for you. So I just wanted to mention that to you. We're not going to implement it, but there is a variation called circular linked list where the last node in the list points to the head node. Okay, that's all for linked lists. I'll see you in the next video.